Today I'm going to be talking about lift. By the end of this presentation, I hope that you'll be able to understand what lift is, how it's generated, and the many constituents of the lift equation. Lift is one of the most important things for an aircraft to be able to produce, as without it, an aircraft will not be able to leave the ground. Lift is generated in different places on different aircraft. For example, the rotors of a helicopter or the wings of a plane. But today, I'm going to be focusing on lift produced by an airplane. Being heavier than air, an aircraft must be able to generate enough lift to overcome the force of gravity. This is achieved through use of its wings. There are two main theories that explain how an aircraft is able to generate lift. One follows Newton's laws of motion, and the other Bernoulli's principle. No one is actually sure which of these is correct, and both sides make compelling arguments. Let's start with Newton. Newton's basic laws of motion can be applied to lift. His first law states that an object in motion or at rest will remain in that state unless acted on by an unbalanced force. When applied to aviation, an aircraft will not be able to leave the ground unless it can generate enough lift. Newton's second law states that the rate of change of momentum of an object is directly proportional to the force acting on it. For a constant mass, force equals mass times acceleration. When applied to an aircraft, the lift of a wing is equal to the change of momentum of air that it is diverting down. Newton's third law states that for every action there is an equal and opposite reaction. According to this law, as air molecules hit an aircraft's wing, they are deflected downwards. This causes a reaction that pushes the wing upwards. The Swiss mathematician Daniel Bernoulli discovered that the pressure of a moving fluid, liquid or gas, varies with its speed of motion. According to Bernoulli, as the velocity of a moving fluid increases, the pressure within it decreases. This theory suggests that as air travels over a wing, its velocity is increased, which decreases its pressure, while air travelling under the wing maintains its low velocity and high pressure. This pressure difference causes the wing to be sucked up into the low pressure region and lift to be generated. It is not yet understood which theory is correct between Newton's third law and Bernoulli's theorem. There are many people on both sides of the debate, with some even believing that both theories work in tandem. Both still give a good explanation on how lift is generated in an airplane. The lift equation is given as follows, with L being lift, CL being the coefficient of lift, P being the air density, V being the airfoil velocity, and S being the surface area of the wing. The coefficient of lift varies depending on the angle of attack of an aircraft. The greater the angle of attack, the greater the coefficient of lift, which means more lift is generated. This is why aircraft adopt a higher angle of attack during takeoff, as at lower velocities, lift is harder to generate, so a higher coefficient of lift is needed. There is a limit to how high an angle of attack a plane can have, to prevent stalling. This is about 20 degrees. Air density differs depending on the climate and weather. For example, on a hot, humid day, the air is less dense, so an aircraft must be flown at a greater airspeed than on a cool, dry day. The surface area of a wing differs from plane to plane. Larger aircraft typically have larger wings and can generate more lift, but way more than smaller aircraft. Some aircraft even have adjustable flaps that the pilot can use to increase the surface area of the wing and generate more lift. The airfoil velocity is arguably the most important constituent of the lift equation. Because velocity is squared in the lift equation, it has a larger influence on the lift than any other part of the equation. For example, an aircraft travelling at the same airspeed, at the same angle of attack, and in the same air density as another aircraft, but with twice the surface area of its wings, will generate twice the lift, whereas an aircraft with the same wing surface area, at the same angle of attack, in the same air density as another aircraft, but at twice the velocity, will generate 4 times the lift of the other aircraft. Anyway, that about wraps up this video. Thank you for watching.